and then share the screen. Okay. Haley, can you see the screen?
Yeah.
Okay, cool beans. Okay, I don't know if this is making much sense to you guys from the lesson, but let's give it a go. All right. So the first question says, so we're on page 185. You're all with me where we are. Okay, and it says practice. So now you're working backwards to how we started. Okay, now you're given probability, and we're finding z scores. In other words, how many normal distributions you are away from the whole sum. So, Adi, let's carry on picking on you. Okay, so what we're going to start, how do we start all these sums?
With the graph.
Okay, draw a diagram, guys. I don't know about you, but I can't do these without one. Okay, so we're not interested in x scores in this case, we're only interested in z scores. Remember, probability is area. Okay, so it's a bit of a weird concept in a way. Probability is the area under the curve, and the maximum probability, okay, so that's what probability is you're working with over here. And the maximum probability for the whole under a normal curve is equal to 1. Okay, so to the right of the mean is 0.5, to the left is 0.5. At the mean, the z-score is 0. It's no standard deviations away from the mean. Now they say, what's the probability that z is greater than a is 0.1589. So now, I need this, okay, is this going to go to the right of the mean or to the left of the mean? If the probability, Haley, of z is bigger than a is 0.1589.
To the right?
What do you want me to do? Yes. Why? Because the area, so remember, a is just as the particular z score we're working with, right? It's just a notation we use. So there's a. I know it's to the right. Why? Because this area over here, okay, is less than 0.5, right? So that area there, that's the area we're talking about. So this area over here is 0.1589. Okay, does that make sense?
Yes.
Okay, so now, okay, we're looking for, because it's bigger than a, so it's to the right of a. So the probability is 0.15. 15% of data is going to be to the right of a. Okay, underneath the curve is 100% of the data. Okay, so now, can I go straight to the table now? Haley, any idea? What I first have to find? I first have to find the table reads off the green part. Okay, remember the table works with this region over here, guys. It reads off between 0 and whatever z score we're working with. Okay, so I've got to find, okay, and then the area, these things are your probabilities. Okay, on the side is the z score, in the middle is your probabilities. Okay, so to work with the probability, I need that region over there. Okay, so how am I going to figure that out?
You're going to say 0.5 minus 0.1589.
Okay, excellent. So therefore, probability that z, is bigger than 0 and, sorry, probability z is bigger than 0 and less than a, okay, is going to be 0.5. What am I writing over here? Okay, probability z is bigger than 0 and less than a is going to be equal to 0.5 minus 0.1589, because that whole area to the right of the mean is 0.5, right? So this is 0.5 minus 0.1589, and it's going to be 0.5 minus, please, if I make a mistake in spots, please shout out. Okay, it's going to be 0.3411. So the area that we're going to look for on the Z table is 0.3411. So now I go to your normal distribution table and I'm looking for an area of 0.3411. So 0.3411 is pretty darn close to this one.
Yeah.
You with me? Okay. You don't have to worry about being, if it's right in the middle of two things, then you can worry about that whole taking the middle of the two scores. But if it's really close to one, okay, then you just worry about, it doesn't have to be exactly. Okay. Oh, Haley, you happy with that reading?
Yeah.
Okay, so what's the Z score?
It's 1.
Okay, so therefore A must be equal to, so this Z score here is 1. So that's you can just answer the question. The question was, what is A? A is equal to 1. So what does that mean? And we could have kind of predicted that. Why? Because remember, right at the beginning, we said that when we started normal distributions, we said that within 1 standard deviation of the mean, remember this, 68% of data approximately lies within 1 standard deviation of the mean. Remember that? That was our 1 standard deviation interval. In the normal distribution, 68% of data will lie within 1 standard deviation of the mean. Okay, so now if this area here in green is 34%, okay, that's why you're getting, okay, in the whole symmetry means that the whole area within 1 standard deviation will be 68%. I don't know if that makes any sense.
It does.
All right. Okay, cool beans. Who can I pick on next? Mari, do you want me to pick on you, or do you want me to just teach it?
So you can pick on me.
Yay. Right. Okay, Mari, let's have a look at the next one. Okay. It says, what's the probability that Z is greater than A is equal to 0.9458? Step 1, Mara, is draw.
Diagram.
Okay, now and remember, we're only working with Z scores, so the mean is 0. So now the question is, okay, if your probability to the right of A is 0.9458, and remember A is a Z score, where's A going to be, to the left of the mean or to the right of the mean?
Left.
And quite far left, do you agree? Because how much this data, so 94 probability of something being bigger than that, so this region over here represents about 95% of all the data. Okay, so A must be quite far to the left. Okay, so this area here, that whole yellow region is 0.9458. Okay, but now, okay, what am I going to have to do in order to read off from the normal distribution table? I'm going to need to know this green area over here. Okay. In other words, I'm going to need to know the probability that Z is less than 0 and greater than this A. Right. So Mara, any suggestions? How are we going to work that out?
0.9458 minus 0.5.
High five yourself, Mara. Right. So that is that over there. Okay. Because this yellow, what's now just yellow, is 0.5, right, to the right. That whole thing is 0.9458. So I'm cutting out the 0.5, and you're going to get 0, what's that? 4458. Am I right?
Yes, sir.
Okay. So that, okay, and remember, it doesn't matter that it's to the left. We're going to, remember, just don't forget that this A, when we write our final answer down, must be negative, eh? Okay, because remember, the table only looks up to the right. What we're actually going to go find is this value over here. Okay, so we're going to go look at 0.4458, and let's go try find it. 0.44. 6352. Well, 58. Do you agree with me? It's kind of in the middle of that lot. Okay, 444. Am I right? 4458.
Yeah.
6 that way, and it's about 5 that way. So let's take it as being in the middle of those two. So what is our Z score going to be? Well, that's 1,600, and this is 1,601. So it's going to be 1, what's that?
605.
Yeah, it is a 1,6005. 2 zeros. Okay. If it's in the middle, it's 3 decimal places. You with me? So we're going to have A, and remember A is negative because it's to the left. But the Z score is going to be negative 1, what did we say? 6005.
Isn't it just 1 0?
1,605. Yes, 1 0. Am I right? 1,60. I'm confusing myself now. No, it's 2 zeros. What do you think, Myra? Let's check. Because if it was
I don't
exactly
know.
here, it would be no, it's Haley, you're right. Sorry. To be 1,60 if it was exactly here, and it'll be 1,61 if it was exactly here. So Haley, you're right. It's 1,605. We end up with 3 decimal places. Sorry. Okay. So you get negative 1,605. Standard deviations to the left. Let's check our answer. Negative 1,60. What are we doing? E. 1,4458. Negative 1,60. Oh, they took it as 0.005. Okay. That's equal to 0.60. Okay, that's right. Okay, we're good with that? Mara, does it make sense?
Yes,
Okay.
sir.
To be quite honest, if you used either of one of those two, in other words, if you used 1,60 and you used 1,61, if you'd used either one of those two, it would be fine. We really don't get too petty with that. Okay. Right. Anyone want to be picked on for the next one? Bianca, do you feel like being picked on or not?
I mean, you can pick on me. Fine.
All right, let's go for it. Okay, right. So G says we want the probability that Z is less than A is 0,2381. Okay, so now we're going to go up to now we've done bigger than A, so the areas have been to the right of wherever A was. Now the area to the left of A, okay, is going to be 0,2381. Okay, so we're going to draw a diagram. Okay, and we're going to get, we're not worried about X scores. At the mean, the Z score is 0. So if the area to the left is 0,2381, is this value of A, the Z score of A, Bianca, going to be to the left of the mean or to the right of the mean, do you think?
The left?
Yeah, because here's A, and the area to the left of A, that area over there, probably a bit more to the right than I've drawn it. In fact, it's probably about, yeah, almost 25%, so it's probably almost halfway through. So A is going to be somewhere around about there, because this area to the left of A is 0,2381. Okay, so good. That's to the left. Okay, am I going to use Bianca 0,2381 on your table?
No.
No, you're going to have to find this region over here, the yellow region. And don't forget, always make a note to yourself perhaps that A has to end up being a negative value. Okay, so to find this yellow region, in other words, the probability that Z lies but is bigger than A and less than 0. Okay, what's that yellow region going to be?
0,5 minus
Good.
0,2.
Excellent. 0,5 minus 0,2381. And if we work that out, we get 0.5 minus 0.2381. Ka-ching. And we get 0,2619. 0,2619. So this area over here is 0,2619. Fish?
Kaposh.
Good. Right. Okay. Right. Let's go. Everyone try on their table first. Go try find this 0,2619. Okay. Remember, we're not given a Z score. We've got the area. So we're going to look up, try find 0,2619. Remember, it goes in some kind of order. Okay. Right. 0,26. Okay. I'd say it's over there. Remember, 0,2642 is quite far away from 0,26. It was 0,2619, eh? So 0,2619, 2619 is only 8 that way, but it's a lot that way. Okay, so I'm just going to go with that score over there. So Bianca, it's going to be what? 0.7?
1.
0.7, 0.71. Good. Okay, but remember, it's to the left. So this must be negative, okay, 0.71 over there. So A is equal to negative 0.71. Okay. We're good with that, Bianca?
Yes, sir.
And I'm just checking the memo now. Ah, we're right. Lovely stuff, lovely stuff. Okay. Righty. Okay. One thing I do like about lockdown is not getting up at like 5 o'clock in the morning. That's the one good thing. Okay, right. I think some of us may actually struggle when we have to go back. A, E, G, what comes next? I said we're going to do K. Right. So question K. Once again, we're still finding Z scores. Okay, and in this case, question K says, find the probability that Z is less than A is equal to 0.8532. Am I right? 0.8532. Okay. Haley, I'm going to go back to picking on you. Or do we have
Hannah's
somebody else
also
here?
here.
Is Hannah here? Hello, Hannah.
Hello, sir.
How are you?
I'm okay. How are you?
All right. Can I pick on you?
Yeah, okay.
Wasn't a very confident answer, Hannah.
No.
Okay, right. So, first of all, draw a diagram, Hannah. Okay. Now, remember, we're just working with Z scores. Okay, and Z is 0 at the mean over there. Okay, and the probability that Z is less than A is 0.85. So less than A, okay, it's to the left of A. So, Hannah, is our value of A going to be to the left of the mean or to the right of the mean, do you think? In
To
order
the
to
right.
get that value. Good, there we go. Okay, so A must be somewhere floating around over there because this whole area over here is 0.8532. Okay, right. So Hannah, the area we need to work with in order to use the normal distribution table is that area, that pink area over there, right?
Yes.
So how can I, which is we could describe as the probability that Z is bigger than 0 and less than A. And how am I going to figure out the size, the area under the curve where the pink region is?
0.8532 minus 0.5.
Well done. Okay, which is going to be 0.3532 if I'm not mistaken. So that, the pink region, that's the whole yellow region. The whole pink region is 0.3532. And remember, A is going to be positive in this case. Okay, guys, so go to your table and go try to find that area of 0.3532. Okay, 0.3532. Well, it's almost spot on. Did you get it there? So what's that going to be, Hannah? It's going to be 1,
0,
0. Yep, that's it. Good. Okay, there you go. What you worried about, Hannah? A is equal to, so A is going to be equal to 1,05. Okay. Now what we're going to do is, after this is what, remember A is what kind of, A is a Z score, don't forget. Okay. And I think in the next few ones, someone's going to do after this, we're going to have to convert that Z score to an X score using the formula that Z is equal to X minus mu over sigma. So we're going to do one extra step now. Okay. Alrighty, guys, let's go. 1K we've done. We're going to try question 2 and question 3. Okay, which is involving X scores. Right. So question 2. And it says, I always, with stats, try, always just start off by writing down a little summary of the important information they give you. So it says a cement company produces bags with a mean weight. So the mean is, what's it, 50 kilograms, eh? Mean is 50 kilograms. Okay. And sigma, standard deviation, is 1,72. If they gave you variance, what would you have to do? Yeah, Haley, I'm picking on you again. If I gave you the variance instead of the standard deviation, to get the standard deviation, what would you do to the variance? Good. You'd square root it.
Yeah, that's it.
Thanks, man. Right. Okay. So it says the weight follows the normal distribution. Right. Determine the weight exceeded by 95% of the cement bags. Okay. So this company produces, okay, cement bags according to those details. Each bag weight has a mean of 50 kilograms and a standard deviation of 1,72. We want to know what weight 95% of the cement bags are bigger than. Okay, so now I'm going to start with Z scores. I'm going to have X scores underneath. Okay, and just kind of get your mind focused. That is, so when Z is 0, what's the X score that goes with it? In other words, what's the mean? The mean here is 50 kilograms, right? We good with that?
Yeah.
Okay. Now they want to know, first of all, we're going to find a Z score. We're going to call that A, that Z score. Okay, where what's happened? 95% of the cement bags, determine the weight exceeded. Yes, I'm right, eh? Okay, so 95% of the cement bags have a weight bigger than this score. So this area over here, what's that area there? That represents 95% of the cement bags have a weight. These are the cement bags which have got a weight bigger than A, eh? 95% exceed that weight. So what's this whole area here? It must be 95% is 0,95. Does that make sense, Eddie?
Yeah, that does.
Okay, right. So now, objective is, first of all, we're going to try to find the Z score using the table. Once we've got the Z score using the table, okay, then we're going to get the X score using the formula. Okay. So first of all, I have to remind yourself this Z score is going to be negative, eh? Okay. So, Haley, I'm going to need the pink area here. How are you going to find that?
I'm going to say 0.95 minus 0.5.
Yep. So probability Z is greater than A, less than 0 is going to be 0.95 minus 0.5, which is 0.45. Okay. So the pink area is 0.45. Okay. Right, guys. So that's what we're going to look for in the table, but remember that our Z score is going to be negative. So go try to look up an area of 0.45 on your table. In this case, it's going to be smack in the middle of 2.
Yeah.
You agree with me? It's right in the middle of those two.
Yeah, 1.645.
So this one is 1.64 and this one is 1.65. So it's going to be 1.645, eh?
Yeah.
Okay.
Just a question. So do you print out a new one
again?
every lesson?
Write it down. Negative 1,645. Say that again.
Do you print one of these every lesson? Because you highlight them all the time.
Yes. In fact, and our print is broken. So poor, you know, Mrs. Littlejohn.
Oh, yes. She has to print them for you.
Yeah, she's my neighbor, so she she has to print these out. Okay. Right. So I get A is equal to the rest of you. Are you happy with that reading? That is negative 1,645.
Yes.
Let me just check that. Yeah, they got the same one in the textbook. Okay. So A is, now we're not done, right? So this is our Z score, which means that whatever weight this is, is, can you hear the violin lessons going on in the background? Probably not. Okay, right. So this is my Z score. In other words, if I'm 1,645 standard deviations to the left of the mean for these cement bags, okay, then 95% of the cement bags will be bigger than that. I need to now convert that Z score into an X score, right? So I'm going to use the fact that Z is equal to X minus mu. Remember, that's on your formula sheet. Okay, we know the Z score and we're looking for the X score. Some people like to put the numbers in first. I like to manipulate the formula first. So if I times by sigma, I get Z sigma plus mu is equal to X. Okay, right. So go try to figure out the X score, everyone. You know your Z score. Your Z score is over there, negative 1,645. Your standard deviation is 1,72. Okay, and mu, okay, is your mean is 50 kilograms for the sample. Okay, so plug those values in and get an X score. Mu was 50, huh? What did you get, Haley? Anyone got an answer?
I got 47.1706.
Me too. Okay, so Z was negative 1,645. Sigma was 1,72. That was your standard deviation. Okay, 50 was your mean. Times those all together, and you get 47,1706. What does that mean? What does that mean? 95% of the cement bags have a weight greater than 47,1706 kilograms. Okay, so that's what you've just worked out. In that particular sample, that's what's going on. Neat, eh? Right, let's just, we're probably not going to get to 3, but let's try to do 2B. Okay. The rest of you okay with that? Silence is consent. Okay.
Yes, sir.
Okay. Right. Let's start 2B. You're going to have to draw a diagram again. Okay. So in 2B, can I turn over? You all got this?
Yes, sir.
Okay. Right. 2B. Okay. Well, we're working again with the same cement bags, and so we just remind ourselves that the mean is 50 kilograms and the standard deviation is 1,72 kilograms. Okay, and it's normally distributed. Okay, it says now the bottom 15% of cement bag weights are disposed of. Determine this disposable weight. Okay, so Myra, I'm picking on you again.
Okay, so
All right, Myra. Okay. Myra, how did you like your choir thing with the American girls?
so it was actually pretty good. I
Yeah, I was
mean,
actually
it went
watching.
as well as it could.
I was watching it live with them. It's quite
it was
funny.
pretty, yeah.
I mean, it is quite amazing that you're having this whole thing with people in New York. But anyway, right. Okay, so we've got our Z scores and our X scores. Our Z there, the Z is at the mean is 0 and X mean is 50. Okay, right. Then it says, so the bottom 15% of cement bag weights are disposed of. So am I going to be to the left or the right, Myra, for this Z score? Of the
Left.
mean. Good. Okay, so here is A, and this region over here is we want to know what's the weight so that I get rid of the bottom 15%. So this is 15%, which is 0.15. Okay. So, Myra, we need the green region. Do you agree?
Yes.
How am I going to get that?
0.5 minus 0.15.
Yep. Tell me what that is.
0.35.
0.5 minus 0.15 equals 0.35. So that is our green region over there. So that's 0.35. Okay. Right. Go to your table, guys, and let's go try to find 0.35. 0.35. Where are you hiding? I'm happy to go with just that one over there. I mean, that's 8 away, but that's 15 away. So I think we can just, we don't have to worry about being in the middle. Okay. It's closer to that. Are you happy with that?
Yes.
So what did you get? What's that going to be then, Myra?
Negative 1.4.
Careful. Negative 1.04, eh? Because that first decimal place is 0.
Negative
Okay.
1.04.
That's it. Okay, so A is equal to negative 1.04. Okay. And so it's just over 1 standard deviation away from the mean, which makes sense because that's about 34%. Okay. So that whole region will be 68%. Anyway, so A is negative 1.04. So that's my Z score. Okay, remember that's a Z score where to the left that I'll dispose is of the bottom 15%. So now I did figure out, take it back to our actual situation. To take it back to our actual situation, what formula are we going to use, Myra?
The one with the
Z.
X and the Z.
Z is equal to X minus mu over sigma. Okay. Everyone go manipulate that formula to get X on its own. So what's X going to be, Myra?
It's gonna be negative 1.04.
And so you're way ahead of me. You're way ahead of me. X is going to be Z times sigma, first of all. Plus mu. Okay. So in this case, yeah, carry on. Z is?
Negative 1.04 times by
Yeah.
1.72 plus 50.
Yeah. Indeed, you are correct, Myra. Okay. Lob that into your calculator. What did you get, Myra?
48,2112 kilograms.
Indeed, fantastic. So what have we worked out? That this company, okay, it will dispose of bags that weigh less, you don't have to write this whole speech down, than 48,2112 kilograms. They'll lob those out. Okay, hopefully they put them back in the cement pile and use them again. All right, guys. Are you getting the hang of this? Myra, you all right with this?
Yes, sir.
It's not too bad, eh? I actually think you've done the hardest section of probability. The hardest section of probability was actually what we did earlier in this year and a bit of last year. All that stuff with combinations and permutations, I think, is the hardest section of probability. All right, guys, go forth into the world and conquer.
Thanks, sir.
Okay, have a good day.
You
Thank
too,
you,
sir.
sir.
Bye.
Bye.